Good evening, everybody. Today is day 12, Math 133, and we are going to talk about the cumulative review number 3. That worksheet is on page 420, 420. And we'll do a little bit of the sample midterm today as well. I think we'll try to get through 2 pages. That's what we got through this morning. Um, and if you want to watch the morning recording, that's up right now. And there's no lecture notes. Okay, so just the cumulative review. So before you go party though, so the exam is next week. It's coming up. So if you're taking it with me on Zoom, we're going to take it next week on Thursday. If you're taking it at the testing center, you can do it Tuesday, Wednesday, Thursday, or Friday next week. Okay. Instead of taking the so you've set aside time in your schedule to watch the lecture notes, right? So instead of using that time to watch the lecture notes, use that time to study. Okay. You've set that time aside in your schedule. There's no lecture notes assigned right now. We'll pick up doing lecture notes again after the midterm is over. So on the day of the midterm, we'll assign the lecture notes for starting with chapter 7. Okay. But for now, use that time that you normally would have, and take a look at some of your other exercises, some of the other, worksheets that we've already worked on, okay? So there's 2 ways to take the exam. You can take the exam with me on Zoom. I will be doing it on Thursday, February 26th from, if you're taking it with me in the morning, 9 a.m. until noon. If you're doing it with me in the evening, we're going to start at 6. Normally we start at 6:30 and go till 8. We're going to start a little early and go a little longer. We're going to go to 6 until 9. Okay. Um, the sample midterm, we're going to work a little bit on that today. The sample midterm is a worksheet. Okay. So it is not the same as the midterm. The sample worksheet is 12 pages long. The midterm itself is 9 pages. Most people are able to do it in 2.5 hours. Okay. There's usually 1 or 2 people in the class that take the full 3 hours. Okay. But if you're worried about time, if you're worried about running out of time, definitely take it at the testing center, because the testing center, they're open from 9 a.m. until 6, Tuesday, Wednesday, and Thursday. They're open from 10 to 2 on Friday. So even 10 to 2 is 4 hours. So even that is longer than what you'll get with me on Zoom. Okay. Um, how many questions are on the midterm? That's a difficult question to answer, because how do you count these questions? So like, this is question number 1 today. We're going to be looking at the cumulative review worksheet, but question number 1, part A has what? It's got 12 different parts, and then so question 1 goes down to F. So is this one question? No, I wouldn't count that as one question. So uh, we're going to do 4 pages today for this worksheet, plus 2 more for the sample midterm. That's 6 pages in an hour and a half. Okay. So 9 pages in 2.5 hours seems pretty reasonable. Okay. Same speed that we would normally work on one of these worksheets. Okay. Does extended time apply for this? So if you have accommodations, then yes, you'll get extra time. Those accommodations are already taken into account. Okay. Um, yeah. So if you take it in person at the testing center, yeah, you have plenty of time. I mean, don't show up at 5 p.m. They close at 6. But if you get there at 2, 2 to 6 is 4 hours. You're not going to need 4 hours. Okay. Well, maybe you will. Depends. You know yourself. You know your testing ability. So, all right. Um, okay, so the cumulative review worksheet that we're going to talk about today is number 3. We're not doing cumulative review number 1. So if you want some extra exercises to practice on, you can try cumulative review number 1. This review today is going to cover chapter 1 through 5. The midterm itself covers chapters 1 through 6. We're going to do the chapter 6 review next week on Tuesday. We've already covered the lecture notes for chapter 6, and Cindy and Elaine have already covered chapter 6 material. So you and I will be working on chapter 6 review on Tuesday. The sample midterm worksheet, that also covers chapters 1 through 6. So any of the pages that we don't get through, Cindy and Elaine will be working on with you guys. So we're going to cover that whole thing. We've already covered 3 pages of it today, or sorry, 3 pages of it. I think we're going to cover 2 more today. So anyway, all right, let's jump into page 420, 420. Grab this. All right, so um, these data represent the number of medals won in the 2024 Paris Olympics from a random sample of the countries that won medals. Find all these things. Okay, so X bar is the mean, right? Standard deviation, and right? So uh, on page 254, there were 3 methods that we talked about on how to calculate mean and standard deviation. Okay. There were 3 methods. Which one would I be using here? So method 1 is from raw data, method 2, frequency distribution, method 3, discrete probability distribution. What do you think? Which method would we want to use in this case? Yeah, method 1. So method 1 is if you have data in a single column. So we're going to be doing method 1. I have 1 column here. If we had a frequency distribution where we have our class midpoints, right? That would be this one, okay? And then probability distribution is from chapter 6. We'll take a look at that on Tuesday, okay? Yeah, so on test day, I'm not going to have hints for you, so you need to know which method to use depending on what you're given, okay? The values above, are these parameters or statistics? Well, that depends on whether you have a population or if you have a sample. What do we have? Yeah, these are statistics because this is a sample of countries, okay? It's not all countries, all right? Metals 1 is a qualitative, quantitative, discrete, continuous. What do you think there? Nathan says discrete, same answer, different answers. You guys agree? No? Yeah. Yeah, absolutely. You can't win half a medal, right? I mean, even if you tie, you both get a medal. Actually, in 2024, there was a really great moment where 2 high jumpers tied for the gold medal, and they both got gold. So, okay, what is the shape of this distribution? So, when we're talking about shape, there were a couple ways you could tell. One is if you had a histogram, you could look at that, right? You can't look at a bar chart if the x-axis is qualitative data, but if you have a histogram drawn, then it's easy to just look at it. We don't have that. So instead, you can compare the mean and the median, which you're going to get from question part A, right? The mean and the median, you can compare those, okay? So that's what you should do here. If you have a box and whisker plot, you can also look and say, all right, are there dots for outliers? Is this whisker or this box bigger on the left or right? Okay. Interpret Q1 in the context of the situation. So on page 253 at the bottom, there is a script for percentiles. Okay. There's 2 bullet points for it, and you can use either one. Script for percentiles. So you write out what the percent is, and then you over here write out what the percentile number is. Okay. So Q1, though, we need that as a percentile. Which percentile is Q1? Yeah, thank you, Mike. 25th percentile. Okay. Peru, country in South America, hopefully everybody knows that geography, won one medal. Calculate Peru's Z-score. So also at the bottom of page 253 is the Z-score stuff. Z equals, you take the value that they give you in the problem minus the mean, and you divide by the standard deviation. Okay. So value minus mean over standard deviation. Now, if you have a population, then the mean is mu and standard deviation is sigma. If you have a sample, it's X bar for the mean and S for the standard deviation. But don't worry about, well, how do I know which one to use? Do I plug in mu or do I plug in X bar? You're never going to have both, okay? The whole point of statistics is we usually can't measure the entire population. Now, in this case, we probably could, right? We could just go to Wikipedia and find out how many medals each country won, okay? But in this case, we have a sample, so we'll be using X bar and S, okay? And plugging those in there. The parentheses around the top, you really only need those when you're plugging it in the calculator. Calculator doesn't know that there are invisible parentheses around the top and bottom of the fraction, okay? You do, so you can put those in. Was Peru unusual? So we had two rules of thumb for if an event is unusual, depending on whether you're looking at a z-score or percents and probabilities. Percents and probabilities, if the probability is less than 5%, we consider that unusual. Each probability has a corresponding z-score with it, and so 5% corresponds with two standard deviations. So if you have a z-score, we would say anything beyond two standard deviations, which means less than -2 or greater than +2, those are considered unusual. Okay. All right. Page 421, Major League Baseball posts data for all its players for the 2024 season, including their at-bats and their hits. So we've got a linear regression. They've already done the StatCrunch for us. So the StatCrunch for this is page 255. Okay. At the top, you can see stat regression, simple linear, if we were going to calculate this out. But they already did it for us, so that was nice. Each dot here represents what? Gary says hits, Mike says players. Yeah, each dot here represents a player. Okay. So if we had the data listed out, you would have two columns of data. You'd have a column of hits and you'd have a column of at-bats. And each row there would represent a player. So each player has a number, how many times they went up to bat and how many hits they got. Okay. And so you could graph that with the scatter plot here. Explanatory variable, that's our x-axis. So that's the independent variable at bats, right? We can see that here at bats. Y-axis is our response variable, so hits. Okay. Equation of the regression line. So y equals, so it's right here. Instead of writing it as hits equals, we'll write it as y equals, okay, or y hat, okay. Technically it's y hat. -7.9, we want two decimal places. 3 plus 0.27x. You can switch the order around. I usually like to have the order switched around, but it's fine. We can list it out the same way StatCrunch does. This is y equals b plus mx. Correlation coefficient. We'll skip that. Find the slope of the regression line. Explain what it means. So this one, there's a script for interpreting the slope. Okay. For Riley Green, a Detroit Tiger in 2024. I'm not sure. I think he still is. X is 512. Find the Y using the linear regression equation. Interpret both values. There's no script for this. Just use logic. Okay. Oh, he is. Yeah, still a Detroit Tiger. Nice. Okay. Um, okay. Uh, I know it doesn't ask for the y-intercept, but a lot of times we ask, you know, does the y-intercept make sense? In this case, the y-intercept is -7. So can you have, if you have 0 at-bats, can you have -7 hits? No, that doesn't make any sense, right? First of all, if you have no at-bats, then that means you you can't have any hits. If you positive or negative. So you certainly can't have negative hits. What does that mean? You hit the ball backwards. Um, and if you have 0 at bats, then you didn't make it to the show. So you would have 0 hits, right? So y-intercept doesn't make sense here. Not that they're asking, but page 422, following graph or table, not graph. Table shows the type of health insurance coverage and race slash ethnicity for a random group of people in the US in 2023. Our column variable is what? What's our column variable? So Nathan says insurance. So each column is an insurance, okay? But our column variable is here, okay? It's this column. Is that right? Does that sound right, Cindy? The column is our race ethnicities. Yes? So that means each row. So the row variable, so we have a row here. This row has all of our headers for insurance. Okay. Type of health insurance coverage is qualitative, quantitative discrete, or quantitative continuous. Kelly says qualitative. So if I asked you what kind of insurance you have, you would answer Medicaid. That's a word, right? That's not a number. So we certainly have numbers here, but these numbers are frequency counts. This is how many people have Medicaid. So it's qualitative. Explain why researchers cannot conduct a designed experiment to obtain data on these variables and the relationships. What do you guys think? So, I mean, is this a design experiment? Like, why can't you do a design experiment? So, a design experiment is where you get a group of people and you randomly assign these people are going to get this, these people are going to get this. Okay. So, for example, if I was studying the effectiveness of a medication, I would get a group of people together and I would randomly split them up and I would give, so this person is going to be part of the control group, so they're going to get a placebo. This person is going to be part of the test group and they're going to get the medicine, the actual medicine, right? So, yeah, that's correct. So, Jordan, you got it. So there's two reasons actually. First of all, you cannot assign race. Okay. Uh, I can't get a group of people together and then randomly group them into different groups and say, all right, Cindy, you're going to be white, Joe, you're going to be black, you're going to be Asian, right? That's not possible. Okay. It's also, and you don't have to write both, but also unethical to assign insurance type, right? I can't get a group of people together in a sample set and say, okay, you're going to have Medicare and you're going to have Medicaid and you're uninsured, right? Sorry, you are now uninsured, right? I mean, I don't think you can't even apply, qualify for Medicare or Medicaid unless you meet certain requirements. So, yeah, you can't just do that. You can't say like, all right, we're going to randomly assign you to military insurance, even though you're not in the military. So this cannot be done as a design experiment. It has to be done as an observational study. Okay. Um, is it unusual to be uninsured in the US? So, uh, if you have z-scores, we look at whether your z-score is more than 2 or less than -2. For probabilities, we'll say that it's unusual if the probability of uninsured is less than 5%. Okay, so you'll have to calculate that probability. Probabilities found from this table, are they classical, empirical, or subjective? It says empirical. Yeah, definitely. We actually did the survey, right? We actually went out and talked to people. So classical is where you're still doing math, you're still calculating probabilities, but you haven't actually done anything. You're just discussing what could happen. You're discussing the chances, what's the sample space look like? Um, how likely is this event to happen versus this one, okay? And subjective is made up, right? So, which doesn't necessarily mean it's useless, but subjective means like, it might not be perfectly accurate, but yeah. We're still going to talk about this, so don't lose this page, because on page 423, we're going to keep talking about insurance and race. On the probability for a single random person in the US that they are on non-group insurance. That's no problem. This one's no problem. So the word not on page 254 at the bottom, there were some rules, and not is for, we use rule 3 to calculate not. So probability that something does not happen is 1 minus the probability that it does happen. Okay. That they are black and on Medicare. That's no big deal. That they're Medicare or Medicaid. So that is going to be either rule 1 or 2 when we see the word or. So probability of this or that, if it's disjoint, we just add them together. If they're not disjoint to do an or, you still add them together, but then you have to subtract where they both happen at the same time. Okay. So to answer question N, it'd be easier if we answer question O first. I don't know why they didn't put it in the right order, but to calculate the probability for part O, this is supposed to be part N. Part N, you had to assume that Medicare and Medicaid are what? So Medicare and Medicaid, are they disjoint or not disjoint? They're disjoint, yes. Okay, so we would use, in that case, rule 1. Okay. Um, yeah, because I think Medicaid is for kids and then Medicare is for elderly. Can you be on both Medicare and Medicaid? I don't think you can. Um, or maybe you can, but at least in our table here, they can't. You are only counted once. So if you're in both, I don't think you can be in both, but um, you would only get counted in one of the columns. So they are disjoint, at least for this exercise. Independent or dependent, if they are disjoint, they're automatically dependent. I mean, you only need to circle one, but there you go. Part P, that they are Hispanic, or again, we're talking about or that they are Hispanic or on uninsured. I don't think you can be on uninsured. You're on the uninsured plan. Um, so this one is going to be rule one or two again, depending on whether those are disjoint or not. So to calculate your probability for part, that's supposed to be a P. P, you had to assume that Hispanic and uninsured are disjoint or not disjoint. For Q, not disjoint or disjoint. What do you guys think for that one? Not disjoint, right? So here's the Hispanic row, and here's the uninsured column, and those cross right here. There are 253 people in our survey that are Hispanic and also uninsured. Okay, so those can happen at the same time, so that'll be rule number two. Okay. Um, Find the probability for two random people in US with replacement. Both of them have employer insurance. So that'll be rule four on page 254. You'll calculate the probability that one person has employer insurance and then multiply that by itself. Okay. Uh, None of them are white. Find the probability that two people, uh, I guess I should say neither of them are white. None of them are white. So this is actually rule three and four. So you'll first want to calculate the probability that one person is not white. And the word not, that's rule three. So one minus probability they are white. Um, that's rule three. And then you'll need to multiply that number by itself twice. So that'll be rule number four. Okay. Lastly, at least one of them is black. That's rule five. And that one's also kind of two problems in one. Rule five, you have to first calculate the probability of not the event and then plug that in here. Okay. Um, that's all the hints. So let's jump back to page 420. Okay.